Welcome to qnawire.
Okay, we have an acetic acid infrared spectrum, and I'm just going to have to sketch this here because we're not allowed to copy and paste the it doesn't matter if here. Okay, this should be about 1700. This should be about 3000. Okay, and then this should be about 1500. Okay. So what they want to see from you is the range for the functional group and fingerprint areas. Okay. So 1500 and below. Okay. This is fingerprint. Okay. This is every acetic acid down here will look basically the same. It'll have the same peaks. But if you don't know it's acetic acid, you're not going to get useful information from these individual peaks. They're basically random. Okay. It can be used to confirm what you have, but it's not going to be used to identify it if you don't know that you have acetic acid. Okay. The functional group region is everything above that, right? These are all the functional group regions. Okay. Next, what functional groups do you have? Okay. Well, you have at 1700, or roughly around 1700, this is your carbonyl stretch, C double bond to O, right? This stretch right here pops up around 1700, depending on whether you have carboxylic acid, an ester, a ketone, aldehyde, etc. Nevertheless, it's usually around 1700. Okay, great. The other thing you have is this alcohol stretch. Okay, this broad band bending around, centered around 3000 is your OH. Okay, that is, it's the oxygen bonded to hydrogen. Okay, and this stretch right here, because of hydrogen bonding, that's why it's so wide, because the strength of this bond can vary wildly depending on the orientation of the molecule with respect to other molecules, right? That's why amine stretches are also really wide like this, right? It's hydrogen bonding. But yeah, this is a characteristic peak. That's your OH stretch. Okay. Next are questions about NMR. Okay, so let's just draw the compound, right? Acetic acid. Okay. Number of peaks associated with the NMR spectrum for the compound. Okay, we're likely talking about proton NMR, I can only assume. Okay, where are there protons on the molecule? Well, there's 3 right here. Okay, and there's 1 right here. Okay, these 3 protons are identical, right? So we should only expect 1 signal from them. Okay, so we should expect 2 peaks. Okay. And then, okay, OH peaks can appear anywhere. It's true. Like they can be all the way downfield or all the way upfield or all the way downfield. So just say anywhere for OH. And then for carbon, which neighbors a carbonyl, we have to look that up on a table. Let me check it out. NMR shift table. I don't remember off the top of my head. Okay. NMR shift for neighboring. That's between 2 and 3. Okay. So this one's between 2 and 3 ppm. Oh, and I guess protons that are on carboxylic acids, supposedly this is between 10 and 12 ppm, but I still feel like they can show up anywhere. But I guess if they want to know specifically. Okay. So 2 peaks, 1 at 2 to 3 ppm and 1 at 10 to 12 ppm. Okay. The type of peaks associated using the n+1 rule, neither of these protons have neighbors. No neighbors. Right? Meaning these are all singlets. Okay. And there should be no splitting, right? No neighbors, no splitting. Oh, fairly simple.